Okay, this is the 2025 Computer Science Higher Level Section C, the programming part of the exam. In the part A, you were given a piece of code, so there's a partly completed function. There's a list of numbers, unsorted, I think. Yeah, unsorted. They're counting how many's in it, and they're adding up all of the numbers to compute a mean at the bottom. All right, so we'll run that code to make sure it works first of all. So that's it there. So the mean percentage mark is this. Okay, so there's no rounding or anything applied there yet. Okay, so let's have a look at the first part. So make the following changes to the program. Round the mean percentage to 2 decimal places. When the program is run, the output should look as follows. Okay, let's do that first. Okay, so it's the very last line here. So we want to format this with an F, and we want to, I'll make this a bit bigger too if I can. Oh, thought I could. Okay, so I'm going to remove this and put this in braces and say dot, I think 0 to F, like that. And of course that has to be closed. I think that's right. Maybe the 0 is not needed. Let's just check. Sorry, like that. Yeah, okay. So you leave the variable intact and colon, and then how many decimal places you needed. So if I needed 3, just to show you, that's how you get 3. Okay. Right, part 2. So what am I going to do with that there now? I'm just going to put part 1 on this. Part 2, they're asking for, currently the code divides the total by 9 to calculate the mean, modified it so that divides the total by the number of elements in the list regardless of its size. Okay, so this is the line they want you to change. So let me leave that line there and just copy it. I'll put in a new line for this. So part 2. And instead of 9 here, what they want you to do is the length, which as it happens is n, because n has already been calculated here. Now you could do it this way too. You could just say length of the results again, but we already have a variable for it, so I think just leave it as n. Okay, we should still get the same answer because n is going to be 9. All right, so that's that second part. The third part, complete the function getGrade so that it sets up all of these things right. Grand, let's do that. So what has it got at the moment? It's got the first 2, so I need elif result is greater than or equal to 50. Grade is equal to merit. If result is greater than or equal to 40, grade is a pass. And if it's less than 40, well, we've already got that covered, right? So if it's any other number, it's going to be unsuccessful, so that's okay. So I think that's it. So I'm going to just say part 3 here for all of these lines. Okay, and the rest was already there. That's fine. Okay. Part 4. Extend the program so that it calls the getGrade function and displays the grade in a message such as the grade for the average is grade, you will need to pass a right. Okay, that's fine. The grade for the average result is lower merit, right? So let's do it like that. So print part IV, print if the grade for the average result is what is it? It is get grade and the number. Okay, so I think that's what we need to do there. Mean even. Okay, so that's mean at the is merit at the moment. Lower merit. Sorry, that should be called lower merit. I made a mistake there. So that one should be lower merit. So that is fine. And now it says lower merit. All right, so that is it for part IV. Okay, the grade for the average. So all you're doing is calling the function, passing in the arithmetic mean into it. Okay, which is what I'm doing there. Right, so part 6, let's see what they want us to do. Part 5. Add code so that the program finds the lowest and highest in results. The program should display this information in 2 separate messages. Okay, let's do it like this. Now you don't have to do it like this, but I'm going to do it like this. I'm going to create a new function. I'm going to say def get min grade and results. I'm going to pass in the whole array into it. If not results, return none because there's nothing in there. Otherwise, return min of results. And we'll do the same for max. So this part here is part 5, min and max functions. Get max grade results. If not results, return none. Otherwise, return max results. Okay, so now what do we say down here? Let's just get our string again. The lowest score is, so print didn't need that there really. Print the lowest score is get min grade results. And we need the same for highest. Okay, so let's try that. Okay, 32 and 88. Is that correct? It is. Okay, do I need anything else there? Highest score, lowest score? No. Okay, add 2 features to count how many scores in results are less than 40. And B, so there's 2 pieces to this, between 50 and 79. Okay, so again, I'm going to use functions here. You wouldn't necessarily have to, but I think it's probably easier. So def get LT40, I'm going to say. Sorry, LT get less than count. Target number and results. Okay, so I'm passing in the array into this. So if not results, just in case, return none. Otherwise, what am I doing? I'm basically going through the whole list for I in results. If I is less than, sorry, is it less than or equal to? Less than 40. Less than target number, then we want to increase the count. LT count, we call it. LT count is equal to 0. LT count plus equals 1. It's going to increase it each time. At the very end, then I'm going to say return LT count. And I think that's right. So if the array is empty, we bomb out and say return 0. We increment this to 0, and then we go through them all. And if I is less than the target number, then we add. If they're all greater than it, then the answer will be 0. Yeah, I think that's okay. So the other one is def. The other one is get in between. So IBWT count. Right, not a very good name there, but
I'm not sure what you mean by in between.
sorry, phone is acting up. Results. So I can take the same approach here. So here we're going to pass in, sorry, it's going to be two numbers. It's going to be start, target, low number, and target high number. Okay, and the results. So first, if not results, then we return 0. The count, so in IBWT count. So if target low number is less than or equal to I, which is also less than or equal to target high num, I think, something like that. Then we want to increase the count. IBWT in between count plus 1. Let's see if that gives us what we want. So now I'm going to call that function, each of those functions. So this is part IV. End part IV. Okay, now down here I need to call those two functions, part IV. Let's see. So the number of scores below 40 is this, and the number of scores between 50 and 79 inclusive is this. So just check that inclusive thing in a second. So print the number of scores below 40 is get less than, what do I call it? Get less than count 40 and results, and print the number of scores between 50 and 79 inclusive is get, go and get the name of that there now, sorry, not a great name maybe, but it'll do fine. So this is going to be 50, this is going to be 79, and this is going to be results. And I think that's right. The number of scores between 50 inclusive is this, 50, 79. Okay, let's see. Oh, I missed a colon up there and there. Okay, so the number less than 40 is 2, is that right? Let's have a look at my list. Well, that's less than 2 and that's less than 2 and the rest of them aren't, so that's fine. The number of scores between 50 and 79, so that one isn't. So this one, and this one, that's 3, 4, 5. So 5 is the right answer. And I think that's what's here as well. Yeah, so that's okay. All right, so that's part, sorry, IV. Right, so this is the last part of the question, part A, which was quite difficult given the constraints of the hour. This would take a bit of time to think about. So what do they want you to do? They want you to detect the largest increasing set of numbers within that list, okay? That's what it happens to be in this case. So 51, 62, 64, 81, they keep increasing. So whenever, if you go through this list, whenever you see a number that's smaller, then it means it's not increasing any longer, so you start again. Okay, so that's what we're doing here. So we have to zip through the whole list, keep adding items to the list, to a new list, as long as they keep increasing. But as soon as they stop increasing, then start again and keep track of it, so that in case you see, you might have one at the start that's got a bunch of 3 in it, but then later on you might get a longer one, in which case you need to cut over to that one. All right, so let's take a look at that. So I'm going to create a function for it. So part bi def find longest increasing run. I'm just going to call it, okay? So that's my list coming in. So if the list is empty, we need to get out of there straight away. If, however, it's not, then what do I need? I need to have 2 lists within this function. One to track the longest one I've seen so far, and another one to track the current one that I'm building up. So current run is equal to, I'm going to make it results. I'm going to make it like that. So basically, it's a list, and there's one item inside it, and it's result 0 to start with. And longest run is actually the same to start with, at least. Okay, so the very first item that's in the list, I know the list is not empty now because I've done that check. So I'm basically putting the first item in there. So now I'm going to go through this whole list now, current run. So for I in range, so I've got the first one plugged in there, so I don't need to go through that again, position 0. I'm going to go from position 1, results. This should be linked results, okay. So what am I checking? I'm checking if the results I is greater than the last value we've just put in, which is always going to be current run minus 1. So that's how you get the last value in a list. So if that is greater than, then I keep adding numbers to the list. So I say current run dot append results I, because the number is still bigger. Okay. Do I need to do anything else there? No, I don't think so. However, if it isn't, it means I have to start again. So I need to now set the latest one. Well, I need to check if it's greater. So if the length of current run is greater than the longest one that I currently have, So if that's the case, then I need to swap them over. I need to say longest run is equal to current run. I'm just assigning the full list in here, so that's how I'll do that. And then what I need to do is say current run. I need to reset current run if you like. Okay. So how do I say that? Well, it's results. So it's no longer I. It's sorry, it is I. So that's where we're starting. That's the first one in there. Okay. So it's the current value that I have. So I'm resetting the array to have one item in it, and it's the current value. All right, so that'll come around again then in the for loop. So it's going to start again. Again, it's going to check if the next one is greater than it. If it's greater than it, it'll add it to the list, and so on, and so on, and so on. So I think that's the basics of the loop we need to have. So then when we come out, I just need to check if I do actually have one that is just one long, because if it's one long, it's really of no use to me. So I'm going to return nothing. So if it's less than that, I'm going to return none. Otherwise, I'll return the whole thing. Return longest run. Okay, I think that's the right logic. All right, so let me just take the name of that function there. Print, what's this thing say? The longest run of result increases is. So the longest run of result increases is and we pass results into it. Okay, I think that should give us what we need there. And this, of course, is part VII. Okay, and now there's my four values. Let's see, are they the same? So 51, 62, 64, and 81. Okay, so I think that's the basics of it. So the loop is the key part there. You keep adding to the list with this line, and then as soon as it's not bigger, you check whether you have a new largest entry. If you do, you swap over to that, so you assign that in there, and then you restart current run every time. Okay, so a bit involved for the 1 hour test, but that's what it was. Okay, next one then was part B. Okay, so it's stats related. You can see the median here. So the median, let's see what they're going to, so they're going to write, they want us to write a program to find the median of a list of 0 or more values. Okay, so this is just the description of what the median is. So what do they want us to do? This is your bullet points. You need to deliver all of these bullets. Okay, so initialize, display, sort, display, and then do the median. All right, let's start with the initialize then. We will have a function for the median. Calc median, we call it. Num list. All right, we'll come back to that in a minute and do that. In the meantime, we have to initialize the list. So let's comment each thing that they've asked us to do. So initialize list of numbers. Number list equals 11, 12, 14, 16, 16, 19, 21, 14, 13, 15, 16. Okay, so they're my numbers. So the first thing they asked us to do is what? Display them. So print the list. Print the list. So let's do that. print the list of numbers, unsorted numbers is number list. Okay, now we're going to sort them. Sort the list, number list dot sort, and then print it again. Okay, so let's just run that first of all. Okay, so there's a sorted list. All right. Now calculate the median. So calculate the median. Let's see what they asked us for. So determine the median, display the median, and display an error message if the list is empty. Okay, the list is empty. Okay, so if we passed in an empty list, let's define one of them too. So empty list equals that. Okay, so this is going to be determine the median. So med equals calculate calc median number number list. All right, and then we're going to print it. Print the median of the list of numbers is median. All right, and the other one we'll do here is median equals calc median, and we'll say empty list. So this should give us an error. Ensure an error is reported. Okay, that's grand. So that's what we need. So now we need to write the function. Okay. Right. So if the number list is empty, so we're going to say if not number list, we're going to say print error list is empty, cannot calculate median. All right, that's that. If it's not empty though, we need to get the length of it. So the length of the list is equal to len from list. Okay. They've given us this information now, so they're saying odd and even. We need to get odd and even, okay? So if it's odd, if length of list is odd, so if len list is divided by 2 is equal to 1, that means it's odd. Then that means this means there is one middle. So let's find it. One middle number. So how do we find it? Well, we can say len list. This guy here will work for us. So middle position is equal to len list floor division 2. That'll give us the middle number, I think. And then I can say return num list middle pos. Okay, if it isn't though, if it isn't odd, it means it's even. I have to get two middle numbers. So this is first middle pause equals len list. And the second middle pause is equal to len list let's think about this. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this happens to be actually do that twice, right? I'm going to do it there and I'm going to do it with the other one as well. Oops. We'll add another number in there to make an odd one. Sorry, even, I mean. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So in that case, when it is even, I am basically looking for dividing it by 12 will give me 6. So I need the fifth one and the sixth one. So I'm just basically going to do it like that. And then I'm going to return the two of these, return num list first middle pause plus num list second middle pause divided by 2. I think that gives it to me. Okay. Let's try it. So this would be num1. Odd list of numbers. So I think that's probably it, is it? Oh, 25. What have I done there now? 25. All right, I'll have to do the two of them there. I'll have to sort the second one as well, obviously. Otherwise it won't work properly. That's all that's wrong there. So I made a bit of work for myself there, but that's okay. That's the same thing down there now. And the same for the second one. Okay, so I think it's all fine. The thing at the bottom, of course, is an issue because this is going to fail. Actually, sorry, if I return none, that'll be fine. That'll be a bit better behaved then. Okay, so error list is empty, cannot calculate median. So that delivers on the requirements. A bit long-winded, so apologies, but that's a reasonable function for the median, I think. Okay, you need to put comments in there as well. I think that was mentioned in the You should use comments throughout to explain your code. Okay. So that's it. So I'll leave it there. So overall, the 2025 paper was very doable, bar the last part of part A that was pretty hard, given the time, given the 1 hour constraint. So I think a lot of people probably won't have got through that, but that probably means the marking scheme will take account of that. Alrighty, thank you.